Alright, let's start the second part. Okay, so I'll go through some libraries which are very useful. Maybe not for today's purpose, but at a certain point you'll use it. There's writing small letters. There's Baggy.js. You will need to look at Fantasyland. Just Google them. Like you may need to Google Fantasyland.js. There is yeah, keep going. Okay. Who's the one with data maybe? Forktail. How do I spell that? Forktail. F-O-R-K-T-A-L-E. Something like that. If you add a JS there, like your Google, it will correct you. There's Sanctuary. Am I missing an A here or something? Well, Google it and it will correct my spelling for you. So the main one is this. Fantasyland is a spec which give you a consistent interface for all the functional stuff. For example, when dealing with a functor, you need to use map instead of other method names. Just naming conventions, all that, and a set of rules you need to follow when you define things. That is Fantasyland. They have a spec for JavaScript. It's not like it's open source and not quite recognized by everyone in this community, but we go with that just because it's there. It's easy to understand. Baggy.js is to do a very simple version of ADT, because ADT it can be very complex, all sorts of restriction constraints you can put on data types and do calculation on type level. But this one only gives you product sum. That's about it. That's enough for the purpose of this course. Forktail.js and Sanctuary.js, you basically pick one of them. This one is a bit lightweight, has some data type defined for you, and this one is a bit of a full-blown, give you many functions to work on. It's like a Lodash. Yeah. I mentioned Lodash, there's a Lambda as well. So if you don't want to deal with full-blown types, and your team may be not on the same level as you, but you still want to introduce functional programming in JavaScript, then the Lambda is a very good way to introduce it. I'll touch on some basic notions here. Lambda.js has many partial functions. What is partial functions? For example, you have a function, let's call it a different name, called prop, equals, you take an object and you take a property name. Actually, I need to reverse them. And the object, and you just do object. Yeah. Just grabbing the property from the object, easy. That is a partial function. Why? First thing, just put partial function aside. Let's talk about that. Undefined. And now. Okay. So the two things it's invented. Okay, doesn't exist in the universe. You have to invent them. Okay. So that is the thing we don't want in functional programming. We don't ever write or getting those things or expecting them to happen. So for any function that potentially will result in returning those two things is a partial function. That's just a term. Okay? So when people say, it's a partial function, that means there's a chance that it will give you these things. When you have those things, you have a chance of error. So that's partial function. We'll discuss a way to deal with them as well. Okay, so those are the libraries. But let's start with the contents for this course. First, we'll talk about curry, and then composition, and then we'll talk about semigroup. There's no hyphen here. Just bring them close. You're right. Semigroup, and then you have noise. These are from here it becomes type. This is a type. This is a type as well. And then you have functor. Inside functor you have maybe not the best way to write this. You have appletive. How to spell it? Am I right? Yeah. Right. Usually, like sometimes people, especially in academics, they call it appletive functor because appletive is a functor. I'm just listing names, the things we will talk about in this class. Okay. And then we will have free appletive functor is a kind of a optional kind of extra thing here. And then you will have, we'll explain what is a monad. Then every one of them will give you a definition, will give you the laws that they must obey in a very loose term. We don't do proofs here, or if you want, we can do that. And we'll give examples and libraries, how to use them, and a bit of code as well. There is free monad. There's a bit of an optional here, free monad. Then there is kind of a tool set here called monad transformer stack. This is a tool to use monad in a particular way. It's quite popular, but it's just popular, so we need to learn it. And then you have what are we? Okay, co-monad. Like code product in category theory, everything has a dual. So co-monad. And then you have co-free. Right. Co-free. Co-free, it is not a monad, it's a co-monad. Co-free, co-monad.
Co-monad.
Yeah, co-monad. So free is a type of monad.
Yeah.
Co-free is type of
Free monad.
co-monad.
Oh, co-monad.
Yeah. Co-free is the opposite, is a dual of free. Yeah. Alright. Here, I think in JavaScript you may not use this, but let's mention here extensive effects. As a particular way of dealing with effects, which Mona and Mona Transformer Stack deal with them as well, just different way. This is a less popular way, but I think it's very flexible. But this is the thing. So after the entire course, at least get rid of the brackets, you know, those things. At least you will understand all of them. Because for those things, I haven't taught before. And I haven't taught them before, those things. But for other things I have, so I infiltrate. Okay. Alright, this is the contents. And we'll start with the first thing. It's going to be a very hands-on session. Okay. So we'll talk about code. In functional programming, it's very common. You know what, let's start with the terminology again. Isomorphism. I hate spelling. How do I spell it?
I-S-O-M-O-R-P-H-I-S-M.
Isomorphism. Alright, so what is isomorphism? You have two things. This covers a very large set of things. One particular thing is, for example, a type. So isomorphism is, what I mean is isomorphism works on type and other things as well. I use type as an example here.
Okay.
Yeah. Right. So you have a string, for example, and you have a not really. Okay. You have a particular type of with this structure. So it's an object of string as key, but this is a special string, like a number string as key. I'm not sure how to construct that type, but it's a number string as key. I'm just describing it, and the value is a number. Right? So it's something like this. Okay, and then you have a structure of an array of number, right? So the index is implied, that means it's a number, right? The number to number, basically, number and number, right? Indexed by number. We see those two things are isomorphic because give you this type, I can produce that type. Give you an array of 1, you can write a function, right? This 1 is like a factory, right? It goes to the factory, and you can write that function. That function exists, so you can have this one out. Yeah? It goes the reverse as well. You have another function can receive that and produce that. So we say the type of this and the type of that is isomorphic. They can be converted, to each other. Yeah. Okay. So, what does that have to do with code? Let's examine this. You have a function which takes 2 parameters. Let's call it. Give it a name. That's the thing we're all good at in programming. It's an add function. We do this. Simple enough? Okay. And you have another add function. This is not valid JavaScript. I'll just put a tick here. Okay. Okay. Those two functions are isomorphic. Got it? Great. Let's, for the purpose of the video, let's prove them are isomorphic. So it requires a mutual conversion, right? So how do that means that exists a function, let's call it f, which take add equals to add apostrophe. Now what's the f? Let's define f. Do this on the fly. Okay. Sorry?
Add.
Add.
It is add.
Add, yeah. So it takes add.
Yeah.
Is that what you mean? Yeah.
And you pass the arguments, AB.
It'll produce that one there. Right? So how do you write it? How do you write it? Just literally tell me.
AB.
A, B. Just tell me everything that I need to write, including brackets,
A,
comma.
B. Yeah. In the brackets.
You want to do this?
Yeah.
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 And what do you do here?
Return A plus B.
Now, okay, first, does it satisfy this requirement? If it takes add here, it will spit our function out. Is this that function? No? Okay, so how do I write it? Obviously, I cannot use the add here when constructing it, right?
Mm-hmm.
So, what I need to do is basically taking
A.
And then take B. And what do we do here? And then I need to produce a result, right?
Yeah.
Return A plus B.
A plus B.
What